So what we're going to do today in section 1.5 is we're going to talk about uncommon unit circle values, meaning that the points that we identified on the unit circle are only a few points. There's an infinite number of points on this circle. So the question is, how can we find the value of the 6 trig functions when we're dealing with points that may not be related to one of our special angles that we identified on the unit circle? So we know you have to read in the directions whether the point is on the unit circle or whether it's not on the unit circle. Because remember, if it's on the unit circle, we know we have a radius of 1. So if this is my unit circle, this has a radius of 1. And if my central angle, if I'm calling is t, again, remember, this is the same as the y coordinate. This is the same as the x if I have a point on the circle. So this all goes back to just setting up your SOHCAHTOA. And then if I know SOHCAHTOA, I can figure out my other 3 reciprocal functions. So sine, remember, is the opposite over hypotenuse. Well, y over 1 is just y. So if you know a point's on the unit circle, then your sine ratio is just going to be y. The reciprocal cosecant will be the reciprocal of y, 1 over y. Cosine, remember, is the adjacent over the hypotenuse, which is x over 1, or just x. And that's why we associate that x coordinate with cosine. The secant is the reciprocal, which is 1 over x. Tangent, I know by my TOA is opposite over adjacent, which is the y over x. Cotangent is going to be the reciprocal x over y. So when you take a look, if they give you a point on the unit circle, again, because it's a point on the unit circle, I know that the radius is 1. So I don't have to set up all these ratios opposite and do all this division. Remember, this x coordinate is the cosine, the y coordinate is the sine. So then I know that the cosine of t, because that's the angle that they're giving you, the cosine of t is just going to be my x coordinate negative square root 39 over 8. Its reciprocal secant is going to be the reciprocal of negative square root 39 over 8, or negative 8 over square root 39. And when I rationalize, that's negative 8 square root 39 over 39. The sine of t is just going to be the y coordinate, and that's going to be 8 over 5. Its reciprocal cosecant of t is going to be equal to 5 over 8. So now to find the tangent, remember, that's going to be the y over the x. So that's division. So I'm going to take my y, which is 5/8. I'm going to divide it by the x coordinate, which is negative square root 39 over 8. And when I divide fractions, remember, I'm going to multiply by the reciprocal. So those 8's cancel out. So I'm left with negative 5 over square root 39, or when I rationalize, that's going to give me negative 5 square root 39 over 39. So the tangent's the one that you'll have to actually do that division and setting up the ratio. The cotangent of t is going to come from taking the reciprocal. Now take the reciprocal of the fraction before you rationalize. So that's going to be negative square root 39 over 5. It'll just save you some time so you don't have to do additional rationalizing of the denominator. So that's, again, you have to read the directions carefully. The only time you can just do the cosine as x and sine as y is if they tell you specifically that it's a point on the unit circle. So for example, when you take a look at b, so again, the cosine of t is the same as my x coordinate, which is negative 3 square root 11 over 10. The secant is going to be negative 10 over 3 square root 11. So I have to multiply top and bottom by square root 11. So this is going to be negative 10 square root 11 all over 3 times 11, which is 33. The sine of t is the same as y coordinate, which is negative 1/10. Its reciprocal is going to be negative 10 over 1, or just negative 10. Tangent, remember, it's y divided by x. So I'm going to take negative 1/10. I'm going to divide it by negative 3 square root 11 over 10, or multiply by the reciprocal. Again, those 10's cancel. So that's going to be 1 over 3 square root 11, because a negative times a negative is a positive. and then I'm going to rationalize. That's going to be square root of 11 over 33. And then finally, to find the cotangent, I'm going to take the reciprocal of the fraction before I rationalize that denominator. So that's going to give me 3 square root of 11. For cotangent, you could always do the x over y, but you'll see you'll get the same answer. So that's how you can find the value of 6 trig functions when you're dealing with an ordered pair that's not associated with one of our special angles from the unit circle. And again, this only applies if the point that they're giving you is on the unit circle. What happens if the trig values are not on the unit circle? Again, all you know is that you have a point on the terminal side of theta. Notice they're not telling you anywhere it's not a unit circle. So we cannot assume that the hypotenuse is 1. This is where you're going to may have to use your Pythagorean theorem to help you find the radius of the circle, which would then turn out to be the hypotenuse. So again, we've got the radius of the circle. Again, we have a point on this particular circle. Remember, with this right triangle, the horizontal side is the same as your x-coordinate. The vertical side is the same as your y-coordinate. So remember, to find if I know the point, to find the radius, I'm going to have to use my Pythagorean theorem. Again, this is only when you know the point is not on the unit circle. Okay? So again, you have to read the directions carefully. Is the point they're giving you on the unit circle, or it's not on the unit circle? So now we're going to talk about what happens, again, when you've got the sign. This got cut off to the other page. So again, looking at your circle, again, the sign is going to be the opposite over the hypotenuse, so that's y over r. The cosecant then would be r over y. Cosine, remember, is the adjacent over the hypotenuse, so that's going to be x over r. The secant is going to be r over x. Tangent is still the opposite over adjacent, so that's going to be y over x, just like it was if the point was on the unit circle. Cotangent is going to be x over y. So we have a point on the terminal side of theta. Nowhere does it say that this point is on the unit circle. So we cannot assume that this radius is 1. So first of all, what I'm going to do is I'm going to plot this point 5, negative 12. I'm going to draw my triangle. So again, I know that this side of the triangle is 5. Now, even though I know technically triangles don't have negative lengths, it is on the negative side of the y-axis. Just so when I'm setting up my ratios and I don't forget about the negative signs, I'm going to label this side of my triangle as negative 12. Before I can find my 6 trig ratios, I'm going to have to find the hypotenuse. So I'm going to have to use my Pythagorean theorem. So I'm going to call r squared is equal to 5 squared plus negative 12 squared. So r squared is 25 plus 144, which is 169. So this is going to be 13. And you may remember those Pythagorean triples as well from geometry. So here's my central angle, theta. So now I'm going to set up my sine ratio. Sine from this triangle is going to be the opposite over hypotenuse, which is negative 12 over 13. Its reciprocal is negative 13 over 12. Cosine of theta is the adjacent over hypotenuse. Its reciprocal, secant of theta, is 13 over 5. Tangent of theta is the opposite over adjacent. Cotangent of theta is the reciprocal, negative 5 over 12. So there's your 6 trig ratio. So like I said, the only difference between the other what you have to do with a point that's not on the unit circle is you have to use your SOHCAHTOA. These are all SOHCAHTOA problems. You have to use your Pythagorean theorem to help you calculate what that radius or the hypotenuse of the triangle is going to be. Again, if a coordinate is negative, label it on the triangle so you don't forget to put those negative signs on the correct ratios. So now I have the point negative 1, negative 2. So that's going to give me an ordered pair down here in quadrant 3. So we're always creating the right angle against the x-axis. So here's your theta. So this side is -1, this side is -2. So then to find the radius, r squared is equal to -1 squared plus -2 squared. So r squared is equal to 1 plus 4, which is 5. So r is going to be equal to the square root of 5. So now I can find the sine of theta. The sine of theta is going to be the opposite over hypotenuse, and then I rationalize that's -2 square root 5 over 5. Its reciprocal, cosecant. Remember, if sine is the opposite over hypotenuse, the cosecant would be hypotenuse over the opposite, so that's your negative square root 5 over 2, or just take the reciprocal of the function before you did the rationalizing. Cosine is the adjacent over the hypotenuse, -1 over square root 5, and that's going to be negative square root 5 over 5. Secant is reciprocal of the cosine, hypotenuse over adjacent, or negative square root 5. Tangent of theta. Tangent is your opposite over adjacent, so that's just going to give me -2 over -1, or just a 2. Cotangent of theta is going to be 1/2. So there's your 6 trig ratios. Again, so you make sure you read your directions carefully. If the point's not on the unit circle, you've got to find the radius by using your Pythagorean theorem. So last one, the point 2, 2. In quadrant 1, there's my point 2, 2. So I know this side's 2, this side's 2. Again, here's my hypotenuse and the right angle. The right angle is always perpendicular against the x-axis. So to find the hypotenuse, I'm going to have to do my Pythagorean theorem. So r squared is equal to 2 squared plus 2 squared. So r squared is equal to 4 plus 4, which is 8. So r is equal to 2 square root 2. So now to set up the sine, and you may start hopefully maybe putting some things together about, both these sides are the same. This is probably a 45, 45, 90 triangle when you take a look at this 2 square root 2 that you got for the hypotenuse. Sine of theta is again, this hypotenuse, the opposite over hypotenuse, so that's 2 over 2 square root 2, 1 over square root 2, which is square root 2 over 2. Should look familiar from your unit circle. Cosecant of theta, reciprocal of the sine, so that's going to be the hypotenuse over opposite, or just square root 2. Cosine. Well, cosine is going to be the adjacent over hypotenuse, which is exactly the same as the sine, so this is going to be square root 2 over 2. The secant is going to be the hypotenuse over the adjacent, or just square root 2. Tangent is the opposite over adjacent, which is 2 over 2, which is just equal to 1. Cotangent is the reciprocal of 1, which is just 1. So even though that point was not on the unit circle, notice those trig values remained the same. Okay? Now, these are all functions that we're dealing with. There are trig functions. So again, just to be comfortable with the function notation that you're seeing, again, instead of writing y equals, we're going to write f of theta. Again, that's just our function notation for sine theta. G of theta is cosine theta. Find the exact value of the functions below if theta is equal to 60 degrees. These are all no calculator questions. Okay? So f of theta over 2. So again, they're telling you theta is 60 degrees. So first of all, I'm going to replace theta with a 60 degrees. So that's going to give me f of 30 degrees. So now remember, when you're dealing with function notation, this number here is your input. So I'm going to take 30 degrees and I'm going to plug it into function f. So what I want to do is f of 30 degrees is going to be equal to the sine of 30 degrees. And again, 30 degrees is on my unit circle. Sine is the y-coordinate. So the y-coordinate at 30 degrees is 1/2. So now g of theta squared. We want to deal with what's on the inside first. So first of all, I'm going to replace theta with 60 degrees. So now g of 60, I'm going to take 60 degrees and plug it in for theta, for cosine. So I have the cosine of 60 degrees squared. So again, 60 degrees is on my unit circle. The x-coordinate, because cosine is the x-coordinate at 60 degrees is 1/2. And I'm going to square my fractions, square the numerator, square the denominator, that's going to be 1/4. So now f of negative theta, so I'm going to replace theta with 60 degrees. So now I need to take my negative 60 degrees, plug it into function f. So now remember, on your unit circle, negative 60 degrees is going to be right here at quadrant 4. Or you can find your positive coterminal angles by adding 360 to negative 60, which puts you at 300 degrees. So at negative 60 degrees, you're exactly at the same angle as 300 degrees. Remember, sine is your y-coordinate at 300 degrees or negative 60 degrees. And again, it's going to be negative because the y-coordinates are negative in quadrant 4, negative square root 3 over 2. So there is your how you're going to be dealing with points that are not on the unit circle.